Hi everyone, welcome back to another video of Engineers Academy. So guys, in our previous video we have seen about the vapor compression refrigeration system which is used in a refrigerator, and we have seen the working of that particular vapor compression refrigeration system. So guys, now over here in this particular video we are going to learn about the vapor absorption refrigeration system, which is nothing but the ammonia based vapor absorption system. So guys, before going to today's topic, I recommend you to watch my previous video, that is of vapor compression refrigeration system. In order to watch that video, you can click over here on the top right corner, and after watching that video only, you will able to understand what is nothing but the vapor absorption system. So guys, let's begin with our today's topic, that is nothing but the vapor absorption refrigeration system, that is aqua ammonia based system basically. And guys, if you are new to my educational channel over here, Engineers Academy, please click on the subscribe button and press the bell icon, so whenever I upload a new video, you will get instant notifications. So guys, without wasting any time, let's begin with our today's topic, that is nothing but the vapor absorption refrigeration system. So guys, I hope you have watched my previous video of vapor compression refrigeration system. Inside that particular vapor compression refrigeration system, there are four major essential components. These are nothing but the compressor, condenser, expansion valve and evaporator. The liquid refrigerant passes from the compressor, which is having high pressure, high temperature, and this particular refrigerant which is there in vapor form, then this particular refrigerant is allowed to pass through the condenser, where it gets condensed into the liquid form, and then that particular liquid refrigerant again allows to pass through the expansion valve into the evaporator, where this particular the refrigerant absorbs all the latent heat of vaporization from the surrounding area, from the outer atmosphere, and we will get the desired cooling effect at the end of the evaporator basically. So now that particular refrigerant is again goes through the compressor, like it will get like the high pressure, high temperature, and again it is passed through the condenser, and then this particular whole cycle gets repeat itself. This is nothing but the VCRS, that is nothing but the vapor compression refrigeration system. So over here the compression will occur in compressor. So this is the reason it is called as the vapor compression refrigeration system. But over here I'm just talking about the vapor absorption system. So over here this compression is totally eliminated, and there is no need of the compressor over here. So over here the compressor is replaced by the absorber and the generator unit. So as you can see over here, this is the block diagram of the vapor absorption system. So over here in vapor absorption there is no compressor is used. So instead of compressor we are using the absorber and the generator unit over here. The refrigerant which is coming out from the evaporator goes into the absorber, and inside that particular absorber I am having the aqua ammonia solution, the ammonia plus water solution, which is at the lower temperature. So basically over here the ammonia is having a property, that is the unique property, is that so when the temperature is less, at that particular less temperature the ammonia is highly soluble in the water, but as the temperature increases, the ammonia tries to escape from the water. Ammonia liberates in the form of high pressure and high temperature. So this is nothing but the unique property of the ammonia. So over here in absorber we will get the solution which is at the lower temperature basically. So that is the aqua ammonia solution. So we can call it as a strong solution also. So this particular aqua ammonia solution gets passed towards the generator by using external pump basically, as you can see over here in this particular block diagram. So external pump is there. So this pump pumps out the aqua ammonia solution from the absorber, and it throws out that solution into the generator. So what happens in the generator? The generator is having the external source of the heat, and then heat is passed towards the generator source in such a way that the temperature of that particular aqua ammonia solution increases, and then the ammonia gets released in the form of high temperature and high pressure. So what is the need of compressor in a previous VCRS vapor compression system? To increase the pressure and increase the temperature of the refrigerant. So over here my refrigerant is nothing but the ammonia, and then this particular ammonia gets released in the form of high pressure and high temperature. So over here the job of compressor is accomplished, and we will get the refrigerant which is at the high pressure and high temperature. Of course we will need a source of heat in the generator. So this particular source of the heat, it can be of the anything, that is of the, it can be of the solar powered also, solar powered heat, or else we can use the waste heat from the boiler, waste heat from the heat exchanger, waste heat from the other heat processing systems, or else from the turbine also. So this particular refrigerant then again passes to my condenser, where it is gets cools down, where it throws out all the latent heat of vaporization, where it gets cools down into the liquid form, and ultimately the same process gets follows as that we have seen in case of vapor compression system. So where the liquid refrigerant then again passes through my expansion valve, and from that particular expansion valve it goes into the evaporator, where it absorbs the latent heat of vaporization from outer atmosphere, and we will get the desired cooling effect over here in vapor absorption system. So after getting the cooling effect, the refrigerant which is at the higher temperature leaves from the evaporator and moves into my absorber. Now this particular absorber needs to be at the lower temperature. So this is the reason this particular absorber is having a coolant pass. It is a sort of the heat exchanger. So main function is to maintain the lower temperature. The less the temperature, the more will be the COP of this particular total cycle. The more will be the coefficient of the performance over here in case of the vapor absorption cycle. So over here at the absorber, okay, the smaller pump is used. This particular smaller pump is used, and this particular smaller pump consumes the electrical energy which is comparatively less than that of the compressor. The compressor we have used in VCRS consumes more electrical energy, but over here this particular small pump consumes very much less amount of the electrical energy. So over here this particular my vapor absorption system is totally like it's totally runs on external heat which is we have supplied into the generator basically. So inside that particular generator, the weak solution gets formed after the ammonia leaves from the system. The weak solution gets formed, and then that particular weak solution is again move towards my absorber unit from the return duct via a simple valve. So this particular return duct is there, as you can see over here in the block diagram. So there is the return duct is also. So this particular weak solution gets mixed with my absorber unit, and inside the absorber unit the strong formation of the strong solution will occur, and then this particular whole process repeat itself. So over here we will get the same COP, coefficient of the performance, as that of we have got this particular vapor compression refrigeration system. To increase the efficiency, we can use the sort of the heat exchanger by the end of the evaporator, or else at the beginning of my condenser unit, so that we can increase the COP of this particular refrigeration system. So also this particular refrigeration system can be used in the heat processing units, where the high amount of the heat which is thrown out from the system, or as the heat is the excreted heat, or else we can call it as from the certain processes the heat is they have thrown out the heat. So by using that particular heat we can generate this desired refrigeration system, or else we can generate this particular cooling effect. Also guys, in case of certain turbines, the main function of the turbine is to run engine to generate the electricity, and it also produces the heat also. So that particular heat which is coming out from the turbine, this particular heat can be used to drive that my vapor absorption system. Also in certain cases this particular vapor absorption system can be of the solar powered as well. The energy, the heat from the sun can be harnessed, and it is then passed towards my generator, so in order to make this particular vapor absorption system work. So this is nothing but the overall working and the application of the vapor absorption system. So guys, I hope you understood this particular simple topic of vapor absorption system, which is nothing but the aqua ammonia based system. So in case of any queries, any doubts, you can comment below, and guys, please do subscribe to my educational channel, Engineers Academy. Thank you so much guys for watching this educational video.